Hello, good morning everyone. Today I'm here again to help you with the chapter called Squares and Square Roots. This is going to be the last part of the square root, and then we're going to start a new chapter. But when I when I was going through your textbook, and then I saw a lot of different questions, lots of algebraic question concept is also there. And then when I read it, the different kind of questions based on the square roots. So we can't ignore that part. Like question number 18 and 19, question number 18, 19, and 20 is totally different. I'm going to do some of the sums. I'm going to do question number 18 for you. Question number 19, you can do it yourself. And question number 20, I will choose one or two from here. And then you can start with another question from question number 20. Okay, so let's start the exercise. Question number 18 says that find the greatest 6-digit number which is a perfect square. Now, mentally you cannot say. It's very impossible. Till 12, yes, we could have said, yeah, this is a number, is a perfect square. But then after, like I said, beyond 12, it's very difficult. And in this question, the long division and prime factorization method is also not directly helpful. So before you start with the methods and all, you need to understand the question first. They are saying find the greatest 6-digit number which is a perfect square. We cannot know about the perfect square directly, but we know what is the greatest 6-digit number. Okay, I can ask you what is the greatest single digit number. So your answer would definitely be 9. Yeah, and if I say what is the greatest double digit number, your answer would be 99. Yeah, similarly, if I ask you what is the greatest 6-digit number, then your answer would be 9, 9, 9, 9, 9, and 9. So look at this, 1, 2, 3, 4, 5, 6. There is no other greatest 6-digit number than this number. This is the greatest 6-digit number. You cannot have greatest 6-digit number than beyond this. They did not say decimal number or something. Digit number, direct number. Okay, so this is the number. Now after knowing greatest 6-digit number, now we need to proceed towards finding the greatest perfect square number. So for that we need to use long division method. Okay, we'll use long division method and then try to find it. And first you start pairing this. Now that's the process of the long division. This is one pair, this is another pair, and then this is pair. So they are perfectly paired. Okay, there are 3 pairs over here. And now let's go to the first pair, 99. Now you need to find the square root, which is squared number which is closest to 99 or equal to 99. You cannot go beyond 99. So I don't think 99 is a perfect square. So definitely we're going to find which is the closest to 899. So let's not start with 2 or 3. It will not make sense. Directly I want to jump into 9. So the 9 into 9 table. 9 into 9 will give us 81. Yeah, so that's 81. And then 10 into 10 is 100. It's going beyond 99, so I can't take that. So 9 is that number. 9 is the squared number, which will give us 81 as your answer. Let's subtract this. So you'll get how much? 9 minus 1 will give us 8. Yeah, and then 9 minus 8 will give us 1. Okay, and let's add this 9 out here, and then you'll get 9 plus 9 equals to 18. Okay, and let's bring this pair down. You get 9 and 9. Now I need to find over here, as we already know, 18 is already there, multiplied by one more digit, multiplied by the same digit should give us close to or equal to 1899. Now the last number over here is 9, as you can see, and I need to find a last digit number which will give us 9. That is 3. 3 will be very small. Let's start with a 7. If I do with 7 and 7 is 49. So I'm getting last number as 9. Let's see, 49 carry over 4. 7 and 8 is 56. 56 plus 4 is how much? 60. Yeah, carry over 6. 7 into 1 is 7. 7 plus 6 is how much? So I think it will give us 13. Yeah, I hope I have not made any mistake over here. 7 into 7 is 49. 56. 56 plus 4 is 60. 7 into 7. 7 plus 6 is also, yeah, 13. 10 plus 3 is 10, 10 that's 6. Okay, 1309. 1309. Okay. Oh no, I can't take this number. I'm so sorry. I can't take this number because I can still try with more number after 7 also. So why not let's try with 9. Okay, that's the greatest number. So single digit number. Let's see, this will help us. Maybe 9 into 9 equals to 81, carry over 8. 9 equals 72. 72 plus 8 equals to 80. Okay, and 9 into 1 is 9. 9 plus 8 is equals to 17. So I think this is very close. 701. And if I increase one more number, I'm sure that definitely this number would exceed 1899. So I'm going to go with 189 into 9. Okay, it will give us 1701. Let's subtract this now. So 9 minus 1 equals to 8. Yeah, and then this will be 9 only, and this will be 1, and this is nothing. Okay, so let's add over here another 9. This will give us 9 plus 9 is 18, carry over 1 is 9, and then 198. Okay, let's bring this pair down. It will give us 9 and 9, 1899. I need one more number. Okay, close number. So let's start again with 19. You continue the process. 1989. Sorry, 198 dash multiplied by the same number. Let's see. Again, let's not waste time. Let's do directly with 9. I think this will help us. 9 into 9 equals to 81. Carry over 8. 9 equals to 8 equals to 72. 72 plus 8 equals to 80. Carry over 9 into 9 is 81. 81 plus 8 equals to 89. 9 into 1 is 9. 9 plus 8 equals to 17. 17901. This is the number I got. I hope I have not made any mistake. 17. Okay, 909. So let's see what we get. So I think you'll get us 9 minus 1 equals to 8, and this will definitely give us this one. Then carry over 118. I think you'll get 9 only, and then 8 minus 7 equals to 1. 1988. Now if you see over here, I'm very sorry, I forgot to write this also. Okay, now if you see over here, the pairs are over. You start with decimal. Okay, you put a decimal over here, and you put a decimal over here, and then you put a 0, is it not? And then the process continues. And then if you continue also, you will notice that another number which will come over here will be 9 only. Okay, and then after getting this, you check out the remainder out here. 1998 is a remainder. So what I need to do is, in order to find your perfect 6-digit square, but it's a 6-digit. Now this will help you. The remainder will help you. Okay, this is the trick now. So therefore, the greatest 6-digit number is 9, 9, 9, 9, 9, and 9. 1, 2, 3, 4, 5, 6-digit number, and the remainder over here is 8, 9, 9, and 1. Okay. Now what I want you to do is, you will subtract this number from here, and then you see how much you will get. 9 minus 8 equals to 1, 0, 0, 8. Okay, 9, 9. Now you check this number. Is this a perfect square? You can check this number by long division method or prime factorizing. You will come to know that yes, this is a perfect square. So this is how we find the greatest 6-digit number which is a perfect square. This process can continue. Greatest 5-digit number which is a perfect square. Greatest 3-digit number which is a perfect square. So this will help you. Okay, this is a method. This is one of the methods to find the greatest 6-digit perfect square. I hope this video which I have made on this question is helping you guys. And then next question, if you see over there in question number 19, find the smallest 6-digit number which is the perfect square. Now the difference between these two questions is that the first one was the greatest 6-digit number and the second was the smallest 6-digit number. Now you need to understand what is the smallest 6-digit number. As you already know, the smallest 6-digit number is equals to not 9 now. The smallest is not 1 1 1 1 1 also. We have smaller number than this, that is 1 0 0 0 0 0. Okay, smallest 6-digit number. The greatest was that, the smallest was this. Okay, just try to understand the difference over here. Now after knowing this, knowing the 6-digit number smallest, the process continues. Again you find the remainder, whatever remainder you get. Okay, if you get in decimal, round it off, and then whatever value you get rounded decimal, round it off, and the remainder which you get, and then you write the answer, this 1 0 0 0 0 0 0, and then we subtract it over here. In the smallest case, you add with the quotient and the remainder. That will give you the greatest smallest 6-digit perfect square number. The only difference between these two is that once you get the remainder of 6-digit number, which is the greatest or the smallest, in the greatest case you need to add, subtract, and in the smallest case you need to add. That's the only difference between these two questions. I hope you have understood. I don't need to do this question, and this will be your homework. You try the sum in the same process and then try to get the answer. The only difference is that in the last one, instead of subtracting, you will add it, and the greatest smallest digit number is not 999. It will be 1 0 0 0 and 5 zeros and 1 number. Okay, so hope you will be able to do question number 19. Now I want to discuss question number 20 over here. Alright, question number 20, the first question given to us over here is number 1, square root of 144. I'm very sorry, it's not 1.4, 1.44 divided by 0.49. Okay, now the question looks complicated because there is decimal. Had there been no decimal, it would be very easy. As you already know, 144 is a perfect square, 49 is a perfect square. So your objective should be getting rid of the decimal number. Now if you also notice one more thing, that the number of places after decimal is 2 in the numerator and in the denominator also. Okay, now what you can do over here is that in order to get rid of decimal, you can do one process over here. That is, you need to multiply both the numerator and the denominator by 100. Why 100? Because we have 2 places of decimals on both the numerator as well as in the denominator. This will help us get rid of decimals. And then let's see how much you'll get. Root over of 144 divided by 49, which is nothing but the square root of 144 is 12 and square root of 49 is 7. 12 by 7 is your answer, or you can get in decimal also if you want after this. Okay, 1 point something unit. Similarly, you have root over of, okay, let's try the sum. You have root over of 0.000, sorry, not 10, it's not there, 25 divided by 0.0196. Okay, 196. Now again you check how many places of decimals are there. 1 2 3 4, 1 2 3 4. So 4 places of decimal multiplied by 1 2 3 4. Okay, 1 2 multiplied by 1 2 2 3 4, and then you will be left with 25 divided by 169. Alright, So you already know the 25 is a perfect square. Now you have to check whether this 196 is a perfect square or not. You can do with the prime factorization method or division method, your choice. Let's start with 2 into the 9 is 18, 8 equals to 16, yeah. Then 2 equals to 4 equals to 8, 2 into 9 equals to 18, then 7 into 7 equals to 49, then 7 into 1 equals to 7. The factors of 196 are 2 into 2 into 7 into 7. Then since it's a squared, let's make them pair. Okay, 2 into 7. Okay, 7 into 2 equals to 14. That means 14 into 14 will give us 196. So 25 square root is 5. 196 equals to 14. So 5 by 14 is your answer for question number 320. Question number 3. Okay, this is how we do for this kind of sums. And let's do one more sum from the same question but different sub question number. That is, now this is some different kind of sum. All right, let's try this question number 27. Root over of 9 divided by, okay, root over of 0.09, okay, plus you have root over of 16 divided by root over of 0.16 plus root over of 25 divided by root over of 0.25. This is the question given to us. Now it looks very complicated, but if you check the numbers, there's some similarity over here, and then there is something we can notice over here. If there is 9 in numerator and there's 0.09, that's the similarity over here. 16, 0.16, 25 divided by 0.25. So there is definitely something that can be done to make the sum look easy. Okay, so root over of 9 is what? 3. Yeah, this you already know. Now for 0.09 also you can do directly. If the root over of 9 is 3, then root over of 0.09 is 0.3, but then I will not do directly. I will show you how it's done. You copy the same thing, 0.09, okay, plus root over 16 is nothing but 4 divided by root over of 0.16. Root over of 25 is 5 divided by root over of 0.25. okay, now the denominator is a big problem right now over here, so let's try to solve this problem. Okay, let's try to solve this problem. Now let's just focus on the denominator over here. You have 0.09, and then this is the chapter where we go back to the fractions chapter, where the conversion of decimal to fraction. Okay, decimal chapter and fraction chapter. So root over you copy as it is, and then this, how many places of decimals are there? 2 places of decimals are there, if you can see. Let's get rid of it. All right, 9 out here. 9 divided by 1 0 0, 2 places of decimal, plus, okay, plus, okay, root over of 16, 0.6 is there. All right, 16, and then the denominator there is how many places of decimals? 1 and 2. We have 1 2, okay, plus you have root over of 25, okay, root over of 25, root over of 25, root over of 25, divided by how many places of decimals are there? 1 2, let 1 0 2 0. Use plus sign, and then you can copy the numerator part. So this is 4 and then this is 5. Okay, now let's just focus on denominator. Now if you see over here 3, there is not a problem. Root over of 9 and 100. Do you think these are perfect square? Definitely. So this is nothing but 3 divided by, is 100 a perfect square? Yes. 10 into 10 is 100. That means 10. Okay, plus 4 divided by root over of 16 divided by 4. Again, 16 is a perfect square, divided by 100 is also a perfect square, plus root over of 5 is already there. Root over of 5 equals 25 equals to 5. Again, divided by 100 is a perfect square. So this is the step we have reached. Okay, 5 divided by 10. So this is nothing but fraction upon fraction, which can be written in different order if you want. Okay, 3 divided by 3, you can write 3 divided by 0.3 also if you want, 4 divided by 0.4 also if you want, 5 divided by 0.5 also. But for others, we have learned like fraction upon fraction. This means nothing but 3 divided by 3 by 10. Yeah, and then if I convert this 3 divide into this division sign into multiplication sign, it will be 10 by 3. Don't you agree? So this is what I'm going to do over here. This is what I'm going to do over here. Okay, I'm going to do direct reciprocate. So 3 divided by 3 by 10 will become 3 multiplied by 10 by 3. Okay, plus 4 multiplied by 10 by 4. I showed you how. Plus 5 multiplied by 10 by 5. Okay, now if you notice over here, this 3 can be cancelled, this 4 can be cancelled, and this 5 can also be cancelled. So you are left with 10 plus 10, 10 plus 10 plus 10, which will give you 30. This is your answer. So this is how we do. I hope you have understood, and then if there's any problem you can ask. Now you can try different questions like question number 10, question number 8, okay, question number 5, question number 7. This all will be a homework. Thank you for watching, and then next video would be based on another chapter. Till that time, please utilize the time properly. I'll give you 1 week time to solve this, and understand. If any doubt, please message me. Alright,